There are two formulas used as the limit definition of the derivative, and I will be using this first form more, but because sometimes questions are asked in this form, I want to talk about both. Now, they both really mean the same thing because you can take this x as a plus h. If you replace x by a plus h, then this thing becomes f of a plus h, and this becomes a plus h minus a, which is just h. And also when x goes to a, when x becomes a goes to a plus h. If you solve this for h, you get 0. So as x goes to a, see, h is x minus a, right? So if x becomes a, h goes to 0. So that's why this thing actually becomes this top one. So there aren't really anything different between the two formulas, except that sometimes when you calculate the limit in this second form, it's easier to calculate, but it has some downsides also. That's why I like to stick to this one. But pictorially, there is also a way to see how these two are different. So let's say you have a function. Here's a, and if you go h to the right, this will be a plus h. So the value of the function will be f of a plus h, and then the value at a will be f of a. And this is really change of y over change of x, right? They both mean change of y over change of x. And change of y here is the difference between these two, so you subtract these two. And then change here is the difference between a plus h and a, so if you subtract a plus h minus a, you get h. And then, since you're trying to change this window size to very, very small quantity, so you approach this down to a very small thing so that you end up with a tangent line. That's how this formula calculates the derivative at a. And the meaning of this derivative would be the slope of the tangent line. On the other hand, this one is mostly the same thing, but it's just the difference is between how you name the other point. So I named this point as a plus h because you went h to the right. Well, some people might just prefer to name that as x, and then you have difference between x and a would be the change of x. So change of x would be terminal minus initial. Always when you calculate the difference of a quantity, change of one quantity is its final value minus initial value. So that's what it is. And their y values are fx and fa. So you do fx minus fa. That gives you your change of y. And therefore, again, you see that you end up with the same idea, which is to calculate the change of y over change of x and send that window size to 0. To shrink this window size to 0, that means x goes close to a. Now let me give you a quick demonstration of how this second formula will sometimes give you a faster derivative. So let's say f of x equals to x squared plus 5x. Okay. Then let's say you wanted to know f prime of 2. Well, in the first form that I said, uses h going to 0, and it's f of 2 plus h. So all these x's are now replaced by 2 plus h, 2 plus h, minus the value at f. Value of f at 2. Let's see, what's f of 2? That's 4, and then plus 10, so that's 14, right? So you subtract 14 and divide it by h. And already you see that it's kind of complicated because you have to expand this, you have to FOIL this out, so it's a lot more calculation involved. But if you use the second formula, x going to 2 of f of x minus f of 2 over x minus 2, that's simply limit x going to 2 of x squared plus 5x is your f of x, and f of 2 is 14. And you divide by x minus 2, and that's easy because you just have to factor this. This factors as x minus 2 times x plus 7, right? So after canceling these, you end up with x plus 7, and you plug in 2, and you end up with 9. So this formula often gives you a simpler calculation, but the downside is if you're looking for f prime of x as a function, you can't use this formula. So I will try to stick to this despite sometimes it's harder because it can be used in more general situations.